Okay, Assalamualaikum warahmatullahi wabarakatuh. So, today we continue with chapter number 8, tissue organ and biophysics. Okay, so we want to see the tissue, the composition of the organ, tissue, and how the organ work. Okay, so we are multicellular organism. Okay, so consists of tissue composed of colonies of cell and extracellular matrices. Okay, and from this tissue we have a we can develop the organ, or our body develop the organ. So several different tissue may function jointly to be an organ. Okay, so these are some some of the system, our organ system. Okay, so first is the circulatory system, lung, heart, okay, nervous system, immune system, and the respiratory system. Okay, so for example, in this figure or in this uh, picture, we see the blood cell. So the blood cell also made of some tissue. Okay, some protein tissue. So for us, the animal tissue. Okay, so we have the epithelial cell control the selective process of material transport. Okay, so we have this membrane cell. Okay, control the transport. So we have the connective tissue. So here connect to part of our organ. Okay, so for example, the composed of nerve cell, endothelial cell, and macrophage cell that remove the debris. Our salopello, for example, contain fibro. Next is contain fibroblastic cell that are responsible for splitting extracellular matrix. Okay, so making our skin, and then crisscross by a network of collagen fiber of varying density. Okay, so that is the tissue, and from this tissue we have the muscle cell. So it will fill with actin, just like our chapter 6, and myosin bundle. So have 4 circular distinct form. These are for our animal tissue. Okay, so skeletal, cardiac, smooth, and myoepithelial system. Okay, okay. So in our body, so we have the pressure. Different part of the organ has a different part of number of pressure. Okay, the number pressure. Okay, so for example, the blood pressure 100 to 140, the salus saraf 8 to 15 millimeter per hg. Okay, so we have this one, bladder 0 to 35, brain 5 to 12, eye 12 to 24, gastron 10 to 24, 20. Okay, intraocular -4 to -8, and middle ear less than 1. Okay, so you can see that different part of our body will have a different number of pressure. Okay, so depend on if this the pressure is higher than this number, so it might damage our body. Okay, so the first one is the human security system. So how we breathe, or how the feeding system. Okay, so here we see that we have the circulation of blood. So the blood will supply the food and oxygen to a certain tissue, and the blood also carry waste product from cell and also distribute heat to equalize the body temperature. Okay, so if one part of our body is uh, high in temperature, so we try to distribute it equally to all the our body. Then the blood also carry hormone that stimulate the activity of organ. Okay, so certain part of our organ will send hormone, so that the organ can function effectively. Okay, and this one distribute antibody to fight infection. Okay, so the red blood or the white blood cell. Okay, and also handle many other function. Okay, throughout this our system. Okay, so what are blood? Blood are the two main components that have two main components. The first one is plasma component is about 90% water, 0.9 salt and 9% protein, sugar and trace of other component. Okay, and the and also the cell. Okay, the cell that combine for making a blanket of the plasma. Okay, so these are the plasma, the white blood and the red blood. Okay, so you can see here these are the blood. Okay, so blood, we have the red blood, erythrocyte. So the red blood will carry oxygen and carbon dioxide to and from the lung by concave shape, diameter of about 7.5 micrometer and density around 5 times 10 to the power 3 kilogram per meter cube. Okay, and 5 times 10 to the power 12 per liter contain. So the white blood leukocyte assistant in combating infection. Okay, so it produce a lot of white blood if we are sick. Come in several subgroups including lymphocyte, lymphocyte, monocyte, and natural killer cell. Differentiate into macrophage to attack and remove foreign cell and okay, and that is the rest is the platelet that repair damaged blood vessel. Okay, so damaged blood vessel we can save with this plate. So these are the red blood. So you can see that these are the concave. Okay, so these are the our human circulatory system. Okay, so we have the head, the lung, the heart, the kidney, the liver, digestive, trunk and leg. Okay, so this one, the red one, the blood with high oxygen, and the blue one is the heart with high in carbon dioxide. Okay, so the is pumping the oxygen to our body, and this one taking all the carbon dioxide from our body to our lung, so that we can uh, our lung, and then we can breathe out the carbon dioxide. Okay, so we have this system in our circulatory system. Okay, cardiovascular system consists of the heart, consists of two pumps connected to by electric pipe. The right side pump oxygen deficient blood to the lung via the pulmonary trunk, and then pass through pulmonary vein to the left side of the heart, which then pump it through the aorta into the arteries that run first into arterial and then very narrow capillaries where the blood gives up its oxygen. Okay, so we can see that it gives this oxygen. Okay, and arteries, okay, carry blood to the organ, muscle, and skin, and the vein return it to the uh, say oxygenated blood finally reach the capillary that are so small that only one red cell can only pass through them at one time. Okay, and then we have the vein. Okay, so these are the uh, cardiovascular system. Okay, so in order for blood to flow through the artery or vein, an external force must be applied. So pumping of our heart, so producing the force. The pressure gradient between the end of the vessel will flow from high pressure to low pressure. This motion continues unless another force acts to prevent them. Prevent flow, example, vessel obstruction. Okay, so this one is kalau salur darah tersumbat. Okay, so we have problem. So the velocity of blood is much greater in major arteries, 0.3 millimeter per second. In bigger uh, arteries than the capillaries. So the capillaries is about 3 times 10 to the power 4 millisecond. Okay, maknanya dekat salur darah yang besar, kelajuan dia tinggi. Dekat capillary, kelajuannya rendah. So this one will make the change in average velocity other than those produced by the heart due to change in the total cross-sectional area of the system during branching. So this one we need to know about the fluid mechanics. Okay. Okay, the total flow rate in the major artery is the same as in the aorta. Since all the blood that pass through the aorta must also pass through the major artery. Okay, so these are the balance. Okay, apa yang masuk sama dengan apa yang keluar. Okay, so the blood velocity. Okay, so from the equation of continuity, A1 V1 equal to A2 V2. These are the cross section of the artery, A1 artery, A2 artery. So the blood, the velocity in first artery is V1, so V2 is equal to this one. Okay, the flow rate of the blood changes rather dynamically as the blood traverses the cardiovascular system. The flow rate through the aorta and the capillaries must be the same. Okay, so aorta and A capillary will be the same. So the total cross section of all capillary is about 400 times that of the aorta. Okay, so we have this aorta, capillaries. Okay, so untuk buat satu aorta ni kita perlukan contohnya 400 capillary bind together. Okay, so these are the cross sectional area, mean flow velocity. Okay, so cross section area tinggi. Okay, flow velocity rendah. Okay, so cross section tinggi, flow rate laju. Okay, cross section. So we have this value. Okay, KU. Okay, is the same whenever the cross section is taken. Okay, so these are S and U. K, S multiplying, so will be the same, equal 1. Okay, so we know that our salur darah bercabang-cabang. Okay, a blood vessel bifurcate into 2 or more daughter vessels. So the parent vessel AP VP equal to AD1 VD1 plus AD2 VD2. So we have the pressure different. Okay, so the heart to aorta and so we have this. You can see that from 100 becomes 97, 85, 55, 20, and then 50. Okay, so for this, okay, so we can see from the Bernoulli equation the pressure for each part. So you can see that if this enter from this low high pressure, and the output is this here. Okay, so solving this or do the modeling about this equation, so we can see that the pressure is equal to the viscosity or the density of the blood, the speed, and this y is the length, this one is your s, but here is y, so y rho, and g is the gravitational tarikan daya gravity. Okay, so this the constant at any part. Okay, so the example, the difference between these two delta p, okay, so it's just 1.2%. So the pressure, the relative pressure decrease in the concentric area. Okay, so the pressure will decrease and decrease, so that will not make the system to blow up, okay, or the blood system to blow up. Okay, and these are the Hagen-Poiseuille law. Okay, so how many blood can pass through the vessel at certain time. So we can see that Q equal to the volumetric flow rate. Okay, so how many? Delta P is the pressure gradient from this one to this one. The length of the tube, this one. R is the radius of this tube. Eta is the fluid viscosity, and R is the distance to flow. Okay, so we can get using this equation, Hagen-Poiseuille law. Okay, so to know the volumetric flow rate at this tube. Okay, this tube or this arteries. Okay, so what we can say about this is that here from this equation, resistance always decrease when radius increase. Okay, when radius increase, and resistance increase when viscosity increase. Okay, so if we put here the viscosity, and these are the radius. Okay, these are the radius. Okay, so these are the value. You can see that bila kita ambil tekanan darah kita, so okay, so we have a pumping, a slug of fluid that advance 4 step back up 1 and repeat the cycle over and over. So we have this systolic and diastolic, tekanan tinggi, tekanan rendah. Okay, so you can see that these are the normal pressure, blood pressure for human. Okay, so this systolic pressure, the contraction of the left ventricle as it forces blood out of the heart. Diastolic pressure, the lowest point. Okay, so this one is the pumping of our heart. Okay, so here we know that when we have the big salur darah yang besar. Okay, so this salur darah is a rigid vessel, so the velocity, the blood velocity in that vessel or this outer is equal to V equal to delta P over 4 L eta R squared minus R small r squared. Okay, where delta P the pressure gradient, L is the length of the vessel, eta is the blood viscosity, R is radius of the vessel, and R is the distance from the center. Okay, so we have this velocity. Okay, so these are the maximum velocity and these are the minimum velocity. Okay, so if we study the fluid mechanics, okay, we know that in the center the velocity of the blood at the center is higher than the velocity of blood near to uh, the membrane, okay, the membrane or the surface of the blood vessel, okay. So because this include the friction, okay. So these are when we have a corner, okay. So FC equal to the F of the corner. So we can see, or we can say that when the blood move from here to here, so when it attached to the corner, so will be uh, different dragging this at this corner, okay. So here FC equal to the force to the this membrane equal to m v squared over r. R is the radius of this uh, cylinder, okay, this cylinder. Okay, so here when we know that the blood the circulatory system change the blood change the oxygen and carbon dioxide on, and the product. So here we can see that uh, this membrane, okay, will allow water, glucose, amino acid, oxygen to enter the cell, and will take out the, the wastewater, what waste carbon dioxide, venous and capillary to the to our heart again. Okay. So these are the regulation. Okay, blood cell. Kalau kita tengok lagi. So here these are the inner blood vessel, and these are uh, cell. Near the cell, so we can see that the water can move in, move up, and all other substance, okay, either can go in, go out, okay. And here the pressure is 35, and this also the pressure equal to 35, okay. So during this movement, very slow movement, so it will enable the interchange of oxygen, carbon dioxide, and so on from this blood membrane, okay, so the blood vessel. Okay, so what we can say about this circulatory system, or the previous one, this figure. Interstitial fluid is regulated by exchange of substance with blood in capillaries. So the blood contains water, glucose, electrolyte, ion, gas, protein, red and white blood cell, and waste materials such and urea. So the pressure are typically 35 milli and at the entrance, and 15 milli at the exit. Okay, so here to be 15. Okay, so water is more concentrated in interstitial fluid than blood. Okay, so here this there is more water here than this one. Okay, so blood pressure near the capillary exit is less than the relative osmotic pressure, and the osmosis carrier water from the interstitial region into the capillary. Okay, this is the interchange. So these are the diagram for this gas exchange. The previous one is the water. Okay, so here we have lung, the arteries, the pressure of, okay, so these are the vein. So the pressure of oxygen is 90 and CO2 is 40. So we can see that O2 is higher, the pressure of O2 is higher than CO2, so there will be an interchange between O2 goes outside the arteries, and CO2 coming into the arteries and will be moving to the lung, or the tissue. Okay, so you can see that here we get this. Okay, and even here the tissue, you can see that PCO2 equal to 60 less than this one, so it will go to the arteries, and here O2 is 40, so 90, so O2 will penetrate the tissue. Okay, so these are the explanation of this one. Okay, so we have this explanation. Okay, so the last one for this slide, not this slide, this part 1. So the heart dynamics. So these are the structure of the blood. Okay, the left, the right vessel, the left vessel. So we have the aorta, pulmonary artery to lung, pulmonary vein from lung, left atrium, O2, rich blood, mitral aortic valve, left ventricle, from head, right atrium, for blood, semilunar transmitted wave, right ventricle, inferior vena, cover from the body. Okay, so this will pump up, and these are pump. Okay, the pumping action of the heart. Okay, the blood will go atria, some blood flow into ventricle. That's the phase of atria. Atria contract, squeezing blood into ventricle. Ventricle just break, and ventricle contract, squeezing blood into aorta and pulmonary artery. Ventricle systole. Okay, so this one. So sending out, pumping in, pumping out. So the power done by our heart. So the power output P, the work done by the heart per second in pumping blood, equal to P equal to FD, where F, okay, F, small f, is the average force exerted by the heart, and D is the distance over which the blood moves in 1 second. Okay, the force, the pressure P exerted by the heart on the aorta multiplied by cross sectional are A of the aorta, F equal to P times A, and the blood flow Q is the volume of blood passing through the aorta in 1 second. So in 1 second, the volume of blood move the distance D equal to Q over A. Okay, so here you can see that the if we have high blood pressure, okay, so it might damage our aorta or our salutara. Okay. Okay, so I think we can stop here for this part.